This video will use notes that you've been given in class. So let's go ahead and introduce what a linear inequality is. So to start with, let's compare it to just graphing a line. So the linear inequality is just a line that you would graph in the plane as you always have done, but the difference is you're going to shade one half of the plane either above the line or below the line. And the shaded region would represent all of the solutions. So the shaded region would represent all the solutions to the linear inequality. Okay, so the old skill would be to just simply graph the line as always. The new skill is going to be either shading above the line or below the line to represent all of the ordered pairs that make the linear inequality true. A linear inequality has two variables in it, x and y. So the first skill is to recognize when you're given ordered pairs whether or not the ordered pairs would be solutions, meaning in the graphed representation, these would be points that would be in the shaded region. So the ordered pair is given with both an x and a y. So a way to quickly test to see whether or not the ordered pair is a solution or not is to evaluate the line for the x and y values. So here I have the line 2x minus 3y is less than 15. If I test the first point in there, I would let x become 2 and y would become 5, and then I would compare that. So here I'm going to have 4 minus 15, which is negative 11. Negative 11 is in fact less than 15, so this is a yes. This is true. Let's test the next point, negative 1, negative 7. So testing negative 1, negative 7, I have 2 times negative 1 minus 3 times negative 7, asking if that is less than 15. So that means I'm going to have negative 2 plus 21 less than 15. 19 is not less than 15, so this is false. This is no. That ordered pair is not a solution. And I will let you do the next two on your own. The notes we're using ask you to put each line in slope-intercept form. You don't really need to do that. You should be able to handle it either way. If the line is presented in standard form, to graph it, remember the slope is negative a over b, and the y-intercept is capital C divided by capital B. So you should be able to handle either form of the line as it's presented. And you always have the option to take this and isolate it, solve it for y, which will give you this. You always have the option to put the line in slope-intercept form, but you should be able to handle it in standard form if that's the way it's presented. And here, if you have the strict inequality, you use a dashed line, and if it contains the less than or equal to, you have a solid line for graphing purposes. And the shading, I'm going to alter the instructions as they're presented here. The best testing point, and we'll do some examples so you'll see what I'm talking about. The best testing point is the origin 0, 0. So unless the line goes through the origin, you can let both x and y become 0, 0, and it will tell you if you're shading above the line, meaning if you're shading the region that would contain 0, 0, or if you're shading the region that does not contain the origin. And let's do a few of these so that you understand a little bit better what I've just said. So here's a good learning example which is presented in standard form. So here the slope is going to be positive 2 over 3. Remember the formula has the negative sign built into it. So in this particular problem, here's my negative sign. The value of A is 2, the value of B is negative 3, so that makes my slope positive 2 over 3. And then I'm going to go through the y-intercept at positive 15 divided by negative 3, which means that my y-intercept is the point 0, negative 5. So that's actually pretty easy to graph. So the first skill is to graph the line. Here's negative 5, and I go up 2 and over 3, up 2 and over 3. So here, this grid doesn't take much, but just to give you a skill, just to present the skill for you. This is a less than, a strict inequality, or it's a less than. So that means that when I graph the line, I don't make it a solid line, I keep it a dashed open line. So now you can see that I've got points, and I'll do region A and region B. I've got region A, which is above the line, and region B, which is below the line. And here's the origin, 0, 0. So I'm going to test the point 0, 0 in this equation, and I'm going to see if I get a true statement or a false statement. So here's my equation. If I let both x and y become 0, then I'm comparing 0 to 15, and I'm asking myself if 0 is less than 15. If that's true, then I'm going to shade region A. If that's false, then I would shade region B. This is a true statement, so that means I'm going to shade region A. I'm going to shade above the line. So that means that any ordered pair in the blue shaded region would make this inequality true. If the line is dashed, that means that points on the line are not solutions. So points on this line are not solutions because it's a dashed line. Okay, let's do another example. Number 1 is already presented for you in slope-intercept form, so let's graph that. Negative 5, and my slope is up 1 and over 3. And plot as many points as the graph will hold so that you get a good representation. Okay, once again, this is a strict, or excuse me, once again, this is just an inequality without the equal. It's a strict inequality without the equal sign to it. So I'm going to graph this with a dashed open line, which means that points on my boundary line are not solutions. It's just simply a boundary in the plane. So I've got region A and I have region B. Here's the origin, 0, 0. So I'm going to test. I'm going to let y become 0. I'm going to let x become 0. And then I'm left comparing 0 to negative 5. And I ask myself if that's a true statement. Is 0 greater than negative 5? And that is true. So that means that all of the solutions for this fall above the line in region A, the region that contains 0, 0. Points on this line are not solutions to this inequality. Let's do another one. Let's do another one that's given in standard form. Let's move to number 6. Actually, yes, 6 is a good one, but let's do 5 first, and then we'll do 6 next. So here's number 5. And my slope for number 5 is positive 1. And the y-intercept here is 8. Actually, the y-intercept is negative 8. The y-intercept would be c divided by b. c is 8. b is negative 1. So the y-intercept is going to be negative 8. Okay? So the only information I need is to figure out where it crosses the y-axis and what the slope is. There's 8, and my slope is positive 1. And this is an inequality. This is a greater than or equal to. So now I'm going to make my boundary line solid, which means that points on this line could be solutions. And now it's time to test my point. So I'm going to here's my origin, 0, 0. If I let both x and y become 0, then this is what I have to compare. Is 0 greater than or equal to 8? That's a false statement. So that means that I'll call once again region A and region B. Since region A contains 0, 0, that means that any ordered pair in region A would not be a solution. Since and when testing 0, 0, I got a false statement, that means I'm going to color below the line. So the red shaded region would contain all of the ordered pairs that would make this inequality true. And let's do number 6, and then I'm going to let you all try some of these on your own. Number 6, my slope is -3/2. This line goes right through the origin. If I have C over B, I'm going to have 0/2, which means I'm starting at the origin. So that means that using the origin, the point 0, 0 as my testing candidate is not going to work. So let me show you how to handle it when this happens. So I start at the origin and I count up 3 and I go over 2. So this line is falling. And let's see, this is a strict inequality, so that means that I'm going to have the open line. So my boundary point splits the plane. I have region A and I have region B. But the origin right here is not a testing candidate because the line goes through the origin. So when this happens, just simply choose a point that clearly falls on one side of the line or the other. And I'm just going to choose the point, I'll go with 5, 5. So I'll let that be my testing point, and you can choose any point that you want. So if I let x become 5, I have 15. If y is 5, I have 10. Is 25 less than 0? No, that's a false statement. And since I chose a point in region A, I made my substitutions and I got a false outcome for this inequality. That means that all of my solutions are in region B. So I would just shade that side of the line. And I will let you try the others on your own.